Hi, so I'm Ryan Louie, and this is joint work with Andy Cohen, Cheng Anna Huang, Michael Terry, Carrie Kai at Google Research. And the problem we were trying to understand is how novices might co-create with a deep generative model. So for novices interested in music composition, the rise of generative AI holds promise. Anyone who wants to create music might use a generative model to enhance their ideas and capabilities, therefore allowing them to create a full composition in partnership with AI. Despite research advances in generative AI's algorithmic performance, it remains unclear what novices actually need when co-creating with these generative models. To understand more clearly the needs of novice composers, we conducted a need-finding study. Novices experience two challenges when using a conventional interface for a generative model. The first challenge was information overload. Although the AI was fluent in creating a full piece of music, the AI also overwhelmed novices when creating too many notes all at once. Managing all notes and voices at once was challenging because parts that sounded off were hard to isolate and correct. Second, novices became frustrated with the AI's non-deterministic output. Novices had musical goals for their composition, but when the generated notes did not match those goals, they felt incapable of providing feedback to control the direction. All they could do was request generated notes over and over, almost like rolling dice, hoping one of the rolls matched their goals. Our need finding demonstrated that the interactive tools for co-creating with generative AI could be better designed. Although the conventional interface used in our need finding study does contain an interactive tool called the infill mask, this wasn't enough to fight these AI-induced challenges. So to better match co-creation needs, we built a system we call co, or collaborative co-creation, which augments conventional generative music interfaces with a set of AI steering tools. Let me show you how it works. So voice lanes allow specifying which voices and for which time steps to generate music. With this capability, users can control the amount of generated content they would like to work with. This was designed to address information overload caused by CocoNet's default capabilities to infill all remaining voices and sections at a time. We implemented two semantic sliders in Coco to constrain generated output along meaningful dimensions, a conventional versus surprising slider, and a major versus minor slider. Third, our example-based slider allowed people to constrain generation to be more similar or different from an existing piece of music. And we provided users multiple alternatives of generated output that they could audition and choose the one closely aligned with their goals. So let me show you how this works with a 1-minute video demo. Oh, let me start it at the beginning. So they're using voice lanes to generate just the bass. With the 3 alternatives, they can select and audition them, and then continue on with their process. They can refine the generated output by adjusting those sliders. After doing one voice, they can move on to other voices and continue setting the initial directions. Finally, they can use the voice lane again to complete all 4 voices. So let me explain how the AI steering tools were able to adjust the AI's generated output. To teach you about the underlying technique, I'll explain how it works to power our example-based slider. So in the interface, the user might use the example-based slider to request music similar to this part. And behind the interface, the model represents the user requests to generate notes similar to this example part, as higher probability of sampling notes within the example. The desired qualities are encoded in a soft prior distribution that has higher probabilities for notes in the example, which you can see in dark orange. Soft priors modulate the generated output without retraining the model. By using soft priors to adjust the model's sampling distribution, we get an adjusted posterior sampling distribution that allows the output to adhere to both the original context encoded in the sampling distribution and these additional user desired qualities encoded in the soft prior distribution. So having built Coco with AI steering tools, we wanted to understand in an evaluation study what impact AI steering tools had on Novice's co-creation process. So we conducted a within subject study with 21 music novices comparing the co-creation process with a conventional interface, which had an infill mask, and Coco, which had the AI steering tools. Participants made 2 compositions using the 2 variants. As a prompt, users were shown images and were asked to compose music that reflected the character and mood of one image of their choosing. We measured the impact of the tools on novices' composing experience, attitudes towards the AI, and their perceptions of the final composition. We found that Coco better helped participants express their goals. They had higher self-efficacy, felt the experience was more engaging, and learned more. No significant difference was found on effort when composing. Our qualitative findings provided insight on why AI steering tools helped novices better express their creative goals. The tools supported users expressing their creative goals by allowing them to assign different parts, different musical qualities. So in this example, a user assigned the soprano voice this alternating pitch pattern to get at a feeling of indecisiveness in a main character, and they added mysterious dinging sounds in the bass voice to give a nice harmonic backdrop. We also found that AI steering tools increased users' control, comprehension, sense of collaboration with the AI, and trust of the AI. Our qualitative findings provided insight on why these tools increase novices' sense of collaboration. So novices felt that with the AI steering tools, the AI could be adjusted to do what they would like it to do, and that they felt the AI had a clear understanding of who was in control. Comparatively, using the conventional interface, users were still optimistic about the AI working like a brilliant composer who work could be outsourced to quickly, but they were pessimistic about its black box persona when trying to communicate with it and take it or leave it attitude when working together. Finally, the tools contributed to a greater sense of ownership of the composition relative to the AI. Participants felt the music was due more to their contribution relative to the AI, felt the music was more complete. And no significant difference was found between the tools when measured on uniqueness. So I feel what we saw that with our qualitative findings was that novices who used the tools were more useful, felt more useful as a composer, which made them feel that the final composition was more due to their contribution. In contrast, novices who generated a majority of the piece at once with the conventional interface felt that the machine was doing all the work. Through our observations of the user's co-creation process, we unexpectedly found that the tools helped users with building their composition bit by bit, debugging the music, and overcoming AI limits. So people using the AI steering tools built up their composition bit by bit by using the AI to generate just a little bit at a time. Generating each bit was a checkpoint to intervene and adjust the AI and its generated output before going on. Let me show you an animation of what this process was like. So they would select maybe the first half of the soprano voice and generate just that bit. And they would continue on, maybe generating 3 other voices in the next measure. Whereas with the convention interface, the music composed was, the novices composed using a sculpting strategy. They would refine the fully auto-completed music by repeatedly using this infill mask, generating lots of notes, but selecting a region they might not like and regenerating it and repeating that process. So you might think that these two strategies are just two preferences between users, but composing bit by bit had a surprising side effect. By building from the ground up, a brick at a time, users developed familiarity with the piece, and that familiarity helped them identify the cause of, say, musical glitches later on, allowing them to really debug the music. In contrast, when sculpting with the conventional interface, novices had less familiarity with how all the voices were interacting, so it was hard to disentangle what causes what. In addition to debugging generated output, users had to deal with limitations in the AI's ability to generate desired musical qualities. You see, many users wanted to control a set of musical primitives or these desired subqualities for expressing their musical goals. The steering tools, again, helped users to overcome these AI limits. For example, they might have relied on the idea that long notes conveyed a sense of calmness, while rising shape and pitches could communicate triumph or escalation. When participants could not find an explicit tool that mapped to their envisioned primitive, they repurposed the steering tools as proxy controls to these underlying primitives. So they might say, like, set the conventional slider to generate music that was not super fast or not with a strong musical intensity, or they use knowledge that different voices correlated with lower and higher pitch ranges to encourage the pitch shape of generated notes. I think what's so interesting about this work is that we found that partitioning and constraining the AI's capabilities through semantically meaningful tools was fundamental to the creative process. We didn't change the model, and we just made these additional interactive tools. And the steering tools made a pivotal difference in people's creative ownership, self-efficacy, and collaboration.